Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is better string. First of all, let us start by understanding the question. What does question say? Given a pair of strings of equal lengths, geek wants to find the better string. The better string is the string having more number of distinct subsequences. If both the strings have equal count of distinct subsequences, then return string 1. So basically what they are saying is that we are given two strings in the input, and whichever string has maximum number of distinct subsequences, we will return them. And if they are equal number of distinct subsequences in both of them, we will return string 1. Now what is a subsequence? A subsequence is a sequence or a string which you get by deleting some or none elements from the original string, right? So let's say you have A, B, C. So if you delete B, you get A, C. So that is a subsequence. Okay, it does not need to be in a continuous manner with respect to original string. Okay, you just delete some of the characters from the original string and whatever is left, but you do not change the order of that. That is called a subsequence. And distinct subsequence means if a same subsequence is repeating two times, then we will count them only once. Okay, so for example, if we have GFG and another is GG, so GFG have 7 distinct subsequences where GGG has 4 distinct subsequences, so GFG will be our answer. Then for the second example, here there is only one subsequence and here also there is one subsequence, so we need to return string 1. You don't need to read input or print anything. Your task is to complete the function better string, which takes string 1 and string 2 as input parameters and returns the better string. The expected time complexity is max of string 1 length into string 2 length, and expected auxiliary space is also max of string 1 length dot string 2 length. Okay, and the constraints are given here. So now if we think about solving this problem, so first of all let us look at the example which was given in the question. So it is GFG and S2 is GGG, right? So if we count the different subsequences for the first string, then it would be G alone, then F alone, then third G alone, then GF, then GG, then FG, and then GFG, right? Now in this case, if you look carefully, and one more is okay, so these are the things which we get. Now here G is common, right? So these are not distinct, so we will remove them. Okay, so there is only one G. Now all of them are distinct, so total is 1 2 3 4 5 6. Okay, you can also consider empty subsequence as a subsequence. Why? Because let's say you deleted all the characters, then that empty string is also a subsequence. Okay, so these are the 7 possibilities. Here one is empty, one is G alone. Let's take all the possible cases. So this G alone, this G alone, this G alone. So G, 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 then first 2G, second 2G. So GG, GG, and all 3 G's, right? Now this is repeating with this, so we will take only once, and these are also repeating, so we will take only once. So 1 2 3 and 4. So here we have 7 distinct subsequences and here we have 4 distinct subsequences. So this is our answer. So that is basically what they are asking. So whenever your characters will be repeated in your string, you will get some subsequences which will be repeated. Okay, so you need to take care of that. Now so what can be the solution? See, one brute force solution to is what? To generate all possible subsequences using recursion. So if the length of the string is n, total number of subsequences will be 2 to the power n. So you generate all different subsequences, add it to a set. So set will contain only unique strings, and then return the size of the stack, right? Because return the size of the set, okay, not stack. So why? Because a set contains only unique elements. Even if you add the same element again, it will count only once, right? So you can do that, okay? Or you can use hash map to see whether a subsequence is coming again or not, and so on. So you can, using recursion, generate all 2 to the power n strings, but this will take big O of 2 to the power n time, okay? And it will give us time limit exceeded, and this is not also our expected time complexity. So now we need to think of something more efficient, right? So what can we do here? So can we basically see at every point of time we are telling either to take a particular element or not to take a particular element, right? Because basically let's say here I have FG. So what I have done, I have taken this element, I have taken this element, and I have not taken the first element, right? So basically in recursion also what we will do, let's say I start with index 0 and my string is empty. Okay, now I say let's say I take the example of, let's say uh, 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 GGF. Okay, let's say I take this example. So for the 0th index and the current subsequence till now is this. Now for 0th index I have two choices, whether to pick that element or not to pick that element. If I do not pick that element, the next choice will be for first index element and my string subsequence will remain empty only. If I pick that, the next choice will be at first index and my string will be G, right? Now again at first index I will have two choices. If I do not pick that element, the next choice will be at second index and my string will remain empty only. If I pick that element, next choice will be at second index and my string will become G. Here also, if I do not choose, the next choice will be at second index and it will remain G only. If I choose the element at the first index, the next choice will be at second index and my subsequence till now will become GG, right? Because at every step I have two choices, either to pick that element or not to pick that element. So in this way we will generate all the and whenever we will now see from here I will go to 3, but 3 I know that there is no index 3 because the length of this is 3. So whenever this index is greater than equal to n, we will add that subsequence generated till now to our answer. Okay. So for example, here I decide not to take the element at second index. So subsequence will remain this only, and here I decided to take it. So my subsequence will become GF. Okay. So now I know that there is no index 3 because 3 is equal to the length of the string. So this is the subsequence generated on this path. Okay, take the element, not take the element, not take the element, take the element, not take the element, take the element. So whenever I get here 3, I will add this to my set. Okay, and in this way I can solve using recursion. But I want to do it more efficiently. So can we think of dynamic programming? We can think of dynamic programming when we get overlapping subproblems, which means smaller subproblems are repeated again and again. So if we see here, see, these are the same small subproblems, right? The subsequence generated till now is G. Here also the subsequence generated till now is G, and here the current index which I am considering is 2. Here also it is 2. So the next whatever I will generate further will be same in both of them. So we are getting overlapping subproblems. So we need to think of dynamic programming. Now in dynamic programming, what we can do is see what will be the state of the dynamic programming. I mean the table form. If I think of tabulation approach, that is try to fill it from bottom to up, then what will be my table? See here. This is string. This is the string in the recursion which I am generating. I do not want string. I just want the count of distinct subsequences, right? So basically, I will count the distinct subsequences for this. I will count the distinct subsequences for this, and whichever will be more distinct subsequences, I will return them. So now here the strings I do not want. So from recursion point of view, if I think I will need a DP table of size n plus 1, where DP of I will be the count of distinct subsequences up till index I. Count of distinct subsequences up till index I. Okay, so all the possible distinct subsequences up till index I. Now how we will calculate it and how we will remove the repeated subsequences, now let's have a look at it with the help of an example. So as we talked that we will take a table of dp n plus 1, where dp of n is the length of the string and dp of I will tell us the count of the distinct subsequences up till index I. So for a particular string, dp of n will tell the count of distinct subsequences up till length n, that is the complete length. Okay, now see what happens whenever we get a new character. The number of subsequences get doubled, but yes, there can be repetitions which we need to remove. So how the subsequences get doubled? Let's say I have a string ABC. Okay, so first of all, the first choice is empty subsequence, right? Now I have to decide on A whether to take it or not take it. If I do not take it, it will remain empty only. If I take it, it will become A. So at present I have these two distinct subsequences. Now for B, either I will take it or not take it. If I do not take it, this empty will remain empty, A will remain A, if I take it and combine it with empty, it will become AB, and if I take B and combine it with A, it will become AB. Are you getting my point? So up till index 0, I had two subsequences, one is empty and one is A. Now for B, I have two choices, either to take it or not to take it. If I do not take it, these two subsequences which I generated till this index will remain as it is. And if I take it, I can attach or concatenate it to this subsequence as well as this subsequence. If I concatenate it here, I will get B. If I concatenate here, I will get AB. So I have these four subsequences till now. Now for C, if I do not take it, this empty will remain empty, A will remain A, B will remain B, and AB will remain AB. If I decide to take C, and if I can concatenate with all these four subsequences, right? I can concatenate it with this, I can concatenate it with this and this and this. If I concatenate it with this, it will become C, with this it will become AC, with this it will become BC, and with this it will become ABC. So here I had one subsequence, then it became 2, then in both these subsequences I either kept them as it is or I added B, so it became 4, and in all these four subsequences I either kept them as it is or I added C, so it became 8. So whenever I get a new character, let's say till index I minus 1, I had 10 subsequences. Now at index I either, so now I want the number of distinct subsequences which up till index I. So either I do not add index I to any of the subsequences, so the 10 which I got till I minus 1 will remain as it is. If I decide to take it, then and I can attach it to all the 10 subsequences which I got till index I minus 1, so it will become 20. So in this way it gets doubled, but whenever there is repetition, we need to take care of that. So now let's have a look at example of repetition, and then we will see what can be the formula. So now let's take one more example. Let us say we have string A, B, C, 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 and we want to count the number of distinct subsequences for this. Let's say A, this is B, this is C, C, and C. Okay. Before A, I will have an empty subsequence. Okay. Now up till index A, up till index 0, so this is index 0, this is index 1, this is 2, this is 3, and this is 4. Here I will be noting down all the subsequences which can occur up till index 1. Here I will note down all the subsequences which can occur up till index 2, up till index 1, here will up till index 0, here up till index 2, here 3, and here 4. Okay, and we will count only distinct subsequences. Since there are repeated characters, there will be repetition, but we will observe how that repetition can be removed. In general, what we observed, dp of I is nothing but 2 times dp of I minus 1. That is what we observed. Whenever we consider the ith character, these are the subsequences which I generated till I minus 1. So for every subsequence, I can either keep it as it is or attach the value at the index I, so it gets doubled. Okay, but how to remove repetition, we will look here. So when I will come at index A, I'll either not add A, so empty will remain empty, or I'll add A to empty, so it will become A. Now when I'll come here, either I can keep this and this as it is, or I can attach B to them. So if I attach B to empty, it will become B, and B to A, it will become AB. Here I can keep as it is, or I can attach C to empty, it will become C, C to A, it will become AC, C to B, it will become BC, C to AB, it will become ABC. Okay. Now here I can either keep them as it is, so A, B, AB, C, AC, BC, ABC. So I decided not to take this element. Or if I decide to take this element, I can attach it at the end of this, I can concatenate it with this. Okay, so let me draw a line like this, so it will become C, or I can concatenate with A, so it will become AC, or I can concatenate it with B, so it will become BC, or I can concatenate it with AB, so it becomes ABC, then CC, C and AC is ACC, C and BC is BCC, C and ABC is ABCC. Okay, now what are the repetitions here? C and C is repeated, AC and AC is repeated, BC and BC is repeated, and ABC and ABC is repeated. Why it is repeating? Because I added C to these 4 characters, these are repeated, right? Now, why are they repeated? When were they first generated? they were first generated when I attached this C with these. Okay, please understand this carefully. What are the repetitions? CC, AC, AC, BC, BC, ABC, ABC. Okay, how am I getting this? These are the 4 subsequences which I got, not considering this C, I got this 8 subsequences. This C, AC, BC and ABC were generated when I attached this C with empty, with A, with B and with AB. So these 4 became here C, AC, BC and ABC, but these 4 were also there where I did not consider this C. Now when I am attaching this C to these 4, it is same as attaching this C to these 4. That's why I am getting C, AC, BC and ABC repeated. So these are not distinct subsequences. So how many distinct subsequence, how many repeated subsequence will get generated in 2 into dp of I? If the character at the current index is coming again, listen this carefully, if the character at the current index is coming again, then the number of distinct subsequences count up till which index? Up till index 1 before the, when that character came before. Okay, so see, when I attach this C, what are the number of different subsequences generated? So let's say that is index which, this is 0, this is 1, this is 2, this is 3 and this is 4. So dp of 2 is how much? 8. There are 8 distinct subsequences up till index 2 which I can generate if I consider the string up till index 2. dp of 3 should be 2 into dp of 2, that is equal to 16, but there are repetition. What is the repetition? First of all, I need to find when did C occurred last. C occurred last at index 2. So the number of subsequences which will be repeated will be equal to the count of distinct subsequences of the index 1 before where C occurred last. C occurred last at 2, 1 before that index is this. This has 4 distinct subsequences, so 4 will be repeated, which we saw here. Okay, so I need to subtract 4, so this will become 12. Now again there is a C. So dp of 4 will be equal to 2 times dp of 3 minus number of distinct subsequences in one index before where C occurred last. So currently I am looking for this index. C occurred last where? At this index, because for this is the last index where C occurred, right? And one index before this has 8 subsequences. So I need to subtract 8 here. These many repetitions will be there. So 2 into dp3 is 12. So 24 minus 8 is 16. Let us have a look here. So for all these subsequences, I can either paste them as it is, not considering this C, because I have 2 choices, either to consider it or not to consider it. So B, AB, C, AC, BC, ABC, these 4 are repeated. So CC, ACC, then BCC and ABCC. Okay. Now these I took as it is, not considering this C, but I can also consider it. So let us consider it. Attach C to empty, it will become C. Attach it to A, it becomes AC. Attach it to AB, it becomes ABC. Then attach it to C, it becomes CC. Attach it to AC, it becomes ACC. Then attach it to BC, it becomes BCC. Attach it to ABC, it becomes ABCC. Attach it to CC, it becomes CCC. Then ACCC, then BCCC and ABCCC, right? Now what I told, there will be 8 repetitions. Why? Because C occurred last year, so the number of elements before that were 8, right? The number of distinct subsequences up till this index is 8. So if I add this C to these 8 subsequences, it would be C, AC, BC, ABC, CC, ACC, BCC, ABCC. Similarly, now these 8 subsequences were here also, empty, A, B, AB, C, AC. So if I add this C to this, it will give me C, AC, BC, ABC, CC, ACC, BCC, ABCC. So these 8 will be repeated. C is here, C is here, AC, AC, BC. What we did mistake here. So we have C, then AC, then there should be also BC, okay, repeated. Here I wrote this became C, then AC, then BC, okay. Here BC is also there, which will be repeated. Then ABC is repeated, then CC is repeated, ACC is repeated, BCC is repeated, and ABCC is repeated. 1 2 3 4 5 6 7 8. There are 8 repetitions, okay. So finally what I got 16 as my answer, and this is my answer. So what we will do is, basically we will say dp of 0 as 1, because if there are no characters, empty subsequence is also in subsequence. Then for all the indexes from I to n, we will say dp of I is equals to 2 times dp of I minus 1 minus repetitions. And how will we get repetitions? Whatever is the character at ith index, we will check its previous occurrence. Suppose its previous occurrence is at index j, then my repetitions would be dp of j minus 1, right? And this will give us the answer. Finally, we will compare dpn of first string and second string. This will give, first will give the distinct subsequences in first string, and we also have for second string, and whichever count is low, we will return that as our answer. Now let's look at its actual implementation. So if we look at the actual implementations, I have taken n as the size of first string and m as the size of second string. Then I have taken two dp table, dp1 of n plus 1 and dp2 of n plus 1. Here it should be m plus 1, but I think in the question they have also said that the string lengths are equal, so no need to worry about that. Then I have taken two last one and last two. What will this denote? So for this, see, here the 0 index will denote what? So here what I have done is, last one of 0 means A. 0 index I am corresponding to A, 1 index I am corresponding to B, 2 index I am corresponding to C, and 25th index I am corresponding to Z. Last one of 0 means if I am at current index and current index has character A, so last one of 0 will tell us the index of last occurrence of A. Last one of 10 will tell me the last occurrence of k in the current string, okay. So because for repetitions we need the last occurrence of that index, so for that I have used last one and last two. This will be for first string, this will be for second string. I have initialized all of them as -1, so -1 will denote that that character has not occurred before, okay. Then dp1 of 0 equals to dp2 of 0. dp1 is for number of distinct subsequences of first string, and this is for second string. Then for I equals to 1 to n, first of all I'll say dp1 of I equals to 2 times dp1 of I minus 1. I'll double the number of distinct subsequences with respect to index I minus 1. Now if the index at if the character at index I minus 1 is repeated, then we will remove the repetitions. Now please don't get confused. Here I am counting dp table with respect to 1 based indexing, okay. So dp1 of 5 will tell me the distinct subsequences considering the first 5 characters, right? Why I have done that? Because I have called dp1 of 0 as 1, that is the empty subsequence is also a subsequence, okay. So this is 1 based index dp table, but my string is 0 based index. So if I am talking about the ith character, that will be at index I minus 1, okay. So that's why here it is I minus 1. If last one of string of I minus 1 minus 97 is to convert the ASCII value from 0 to 25. So if this character is not -1, it means this has occurred before. Then dp1 equals to dp1 of I minus dp1 of last of this last string 1 of I minus 1 minus 97 will give me the last occurred index of that character, okay. Let's say it returns j, then we need to remove the elements up till j minus 1. So here I have also done -1, okay. So this will remove the repetitions, and last one of the character which is at current index I minus 1 gets updated to I, okay. So last one of string of I minus 1 minus 97 gets updated to I, because this is at current index. So for further indexes, this current position is the last occurring position, right? Similarly I have done for string 2. So for I equals to 1 to m, first of all multiply it by 2, then if there is repetition, remove it and then update the last position. If dp1 of n, what does dp1 of n say? number of distinct subsequences of first string considering the first n characters. Now what does considering first n character means? Considering the whole string is greater than equal to dp2 of m. So the count of distinct subsequences of first string is greater than equal to count of distinct subsequences of second string or equal, then return string 1, else you will return string 2. Okay, what will be the time complexity? Time complexity would be big O of max of n and m, but if both of them are equal, you can take any one of them, right? Because we are running 2 for loops of those size. And what would be the auxiliary space? The auxiliary space will also be equal to big O of max of n comma m, right? Because we are using this dp table which are of size n and m respectively. I hope you understood this. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you understood the solution completely. Thank you.